This video will cover inequality word problems. I recommend you have a pencil, a piece of paper to jot down some notes about the key words, and of course, a growth mindset. The goal of the video is that when you see word problems like these two, you'll understand what no more than refers to, or at least. So you'll understand why the inequality would look like this and the graph that matches it, and why this one would look like this, and this is the graph that would represent this situation. So just to warm up our brains a little bit, want to know, do you agree or disagree with this inequality statement? If you said agree, then great, because -3 is less than 8, or you could think of it as 8 is greater than -3. Do you agree or disagree with this inequality? This is also correct because -4 does not equal 4. What about this one? If you said you agree, then that means you might not have multiplied the numbers accurately. So 12 times 4 is 48, which is less than 8 times 8, which is 64. So this was a disagree. What about this statement here? Do you agree or disagree? If x equals 15, then x is less than 20. Well, 15 is less than 20, so agree is correct. Last warm-up problem. Do you agree or disagree with this one? If you substitute -2 for x in the inequality down here, you're going to get 16 is less than -11 times -2. When you multiply two negatives, they equal a positive 22 in this case, and 16 is less than positive 22, so agree was correct. So these are going to be the key words that you are expected to know with inequalities and can be represented in various situations. So this symbol can be represented by the word less than. It also represents under. For example, if you are under 2 years old, you should not play with marbles. So that would be a situation. Below 2, you can think of below 2 years old or below 2 feet. And it's going to be on a graph, open circle to the left, because all values that are less than 2 but not equal to 2. Over here we have the greater than sign, so values are more than 4, greater than 4, or over 4. So like on a roller coaster, if you have to be over 4 feet, technically if you're 4 feet, you're not tall enough because you have to be over 4 feet. So therefore, open circle, 4 is not included, but anything greater than 4 is true. The other types, we have the less than or equal to symbol. In this case, all values less than or equal to 6. A maximum of 6, you can think of it like people. A maximum of 6 people can go in the van. That's how many seatbelts there are. So you could have 6 or less. Same thing as no more than. So if you think of more than, that means greater, but if you add the no to it, then it switches it around. So therefore 6 can be included. It has the equal to symbol or a line in the symbol, and less than. Over here we have the greater than or equal to, so it's more than or equal to or greater than or equal to. Another keyword for that is at least. So if you think of money, you need to have at least $8 to pay for the movie ticket. So that means you could have $8 or more. At least 8 is that or greater. And same thing over here. So it's the opposite of no more than. We have no less than. So less than means less. No makes it the opposite of. No less than $8. It's 8 or more. So shaded and circled to graphic because it has the equal to line in the symbol and more than to the right. So here is a first word problem. Jimmy's dad told him not to turn on the air conditioner unless the temperature was at least 82 degrees. Define a variable and write an inequality for the temperatures at which Jimmy can turn on the air conditioner. And we also are going to be graphing the solutions. So first off, we need to define a variable. This is temperature in degrees. So we could use T or D for degrees. I'm using T for the temperature in degrees. The keyword at least. So if we think about, is 82 degrees included in that? At least 82 degrees. Well, if it's 82 degrees, then that is the bare minimum. And then the dad said if it's hotter than that, the temperature can be turned on. So the temperature has to be Here's also a reminder, at least is greater than or equal to the value. So the temperature has to be greater than 82 or equal to 82. So that would be our inequality. And we need to graph them. So on a number line, we're going to have 82. It's going to be equal to 82 or greater. So it's going to point to the right. So 83 degrees or hotter. Here's another example. It is recommended that the pool capacity at the community pool stay under 100 people. Define a variable and write an inequality for the situation. We're graphing this one also. So defining a variable. Well, in this case, it says under 100 people. So the number of people, you could do P for number of people, or S for number of swimmers, or however you want to do that. Is 100 included in the possible solution? So it has to be under 100. So technically if there's 100, that's not under 100, that's equal to 100. So therefore it's not included. So people has to be, and one reminder back on this sheet, we had under 2 being the less than. So P is less than 100, the number of people less than 100. And I'm adding a little note here. It has to be whole numbers. You can't have part of a person. So in this case, it would be 99, 98, and not anything in between. On the last one for temperature, it didn't have to be whole numbers because you'd have 82.1 degrees, 83.5 degrees. So decimals would make sense in temperature, but they do not make sense with people. Whole numbers make sense. So we're going to graph this one. We have not closed circle here. We have open circle because 100 is not included, and then anything under that, which is less than, so pointing to the left. Now we have a couple for you to try. Please read the problem and think about what the variable could represent. So on this one, we have boxes of Girl Scout cookies. So you could use B for boxes or C for cookies. I use B for the number of boxes. So the inequality, what would that look like for this one? They need to sell at least 500 boxes. So therefore, at least means the need to be 500 or more. And to graph it, shaded in circle at 500, greater than would point then to the right. I like to have at least one point on my number line showing that this is the smaller side or the greater side, so at least one other point other than the end point. And I also added on this one whole numbers because you really don't sell part of a box. You're not going to sell 499 and a half boxes or something like that. Here's the next one. So in this case, we're talking about the age or the years old of a kid. So Y for years or A for the age. What would the inequality look like? Well, it says they have to be under 10 years old. So that would be less than 10. So on the number line, 10 is not included. This is the actual age range. It's 3 to 9 for the kid ticket. So under 10, in this case, we're saying under 10. And realistically, you can't have anyone less than 0 or equal to 0 in that case. That wouldn't even be born. So this is called a compound inequality. It's just some little bit of extra information in this video. This means the age has to be greater than 0 and less than 10, but you don't have to know this at this point yet. And then the last one for you to try. So defining a variable, it's the number of customers. So you could use any letter you like, but it has to do with the number of people. Customers need the maximum capacity. So maximum means it has to be this number or less. So you could have 60, that's the maximum, but it has to be under that or equal to 60. So therefore, if we graph it, it's going to be a shaded in circle because it could be equal to 60, and then it's everything less. And once again, can't have less than 0 customers, can't have negative customers. So technically, the customers could be equal to or greater than 0 or less than or equal to 60. But once again, this is a compound inequality, just a little bit of extra information based on the situation, but not something you have to do yet. So for the practice today, I want you to go onto IXL and just do some basic graphing practice, but I want to show you some pointers on there because it can be a little frustrating if you don't know how to do some things. So on IXL, when you click on the link, it's going to take you to this 7th grade inequality graphing practice. Want to point out, you can click on see an example, and it'll kind of show you an example, which is always helpful. But now what's going to happen is you're going to get a problem like this. So you're going to click on the endpoint to graph it. Now, if you click once, it'll be closed circle. If you need an open circle, you need to click again. And then let's say you just stop here, like you're saying graph it to the right, which is correct, but right now it'll be marked wrong because you don't have an arrow. So I actually got stuck for a little bit trying to figure out how to delete this, but it does say click the middle to delete it. And you'll have to start over. So once again, I'm going to need open circle, and then I'm going to have to drag all the way to the side to get the arrow. That's how you would get it right. So let's do one more. So here we have 10 as the endpoint. Now on this one, it has the equal to, so it is solid. And you're going to drag it all the way to the other side to get the arrow to show that it goes on forever. And then that's how you will get these correct. So that's the type of practice I'd like you to do to show you're learning inequalities. You got this. Do your best. Growth mindset. See you on the next lesson video.